Let's have a look at some sample ones then. Maybe this will help us with the astroblaster question. We have a 4 kilogram ball moving at 4 meters per second east, striking another 2 kilogram one at rest. If the final velocity of the 4 kilogram ball is 2 meters per second east, find the final velocity of the smaller mass. Oh, yeah. Do you get the feeling that a picture might help?
Yeah.
Okay, so we've got a 4 kilogram ball moving at 4 meters per second east, striking another one at rest. Do you want to call these A and B? I think A and B works better because numbers tend to be confused with like the speed and the mass and everything, right? So let's call this one A and we'll call this one B. Carter, put it away and pay attention. Here's the learning part. You did really well yesterday, as did everyone. I think we learned yesterday we can get through a full hour. Fair enough, fair. Okay, so we've got A moving at 4 meters per second, striking B at rest. Right? After the collision, A is moving at 2 meters per second, and B is moving at some unknown velocity, right? That's what's happening. How do you feel about this PI equals PF and like sort of one great big giant thing? Or would you rather do like initial calculations and then transfer it to final calculations? How do you guys feel about that? Or do you want me to sort of do it both ways and then you can make, you like the big one? Do you guys know what I'm talking about? Do you want me to go, don't write this down. Do you want me to go PI equals PF and then go blah, 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 equals, blah, 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 and then have a thing at the end? Or would you rather see PI equals, work out, blah, 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 work out some value here, and then take that and then go PF equals, and then work that out over here? Like, do you want to see them, do you want to see it happen simultaneously, or do you want me to do the PI first, and then flip it over to the PF and work it that way?
Which one's more beneficial?
I don't know. It's just kind of personal favorite.
Find the first one, it's easy, just as long as you know how to organize yourself.
Yeah. Okay, well, I'll do this one that way then. So, PI is PF. What does that mean? Initial momentum is equal to final momentum. Right? So, what makes up the initial momentum? Well, we've got balls A and balls B, so it's going to be MAVA plus MBVB, right? I mean, reality, Dan, all I'm doing is I'm doing left, I mean, you could do it, all this left step and then just, right? What makes up the final momentum? Mass of A, velocity A, but is that velocity A the same? That's the little prime thingy, right? Which means after collision. Plus MBVB prime. Does it have to be a different color? No. Will I forget to change it to a different color at times? Yes, like. The mass of A is 4. The velocity of A also 4. Mass of B, 2. Velocity of B, it's at rest. Sometimes, Dan, you can do it this way too, right? Like you could just go 8 plus 0. I mean, you could do that too, right? I tend to sort of do that too. So that means that the initial momentum is 8, right? And that has to equal what's happening on the other side, the final.
Wait. 4 times 4 plus 2 is not 8.
You're right.
18.
No, it's actually
4 times 4 is
2 times 0 is 0.
And then
16. But you're right. So MA here would be 4. We're looking for the smaller mass, which is of the B1. So A moving after is 2. So 4 times 2. The smaller one is 2 VB prime. Question, Joel? The little red thing, yes. That's what we went through yesterday. I know, you should be here every day. Absolutely, yeah. AJ and Kale will make sure they get all plugged in. The little prime thing, Joel, means after the collision. It's a way of denoting that this is the velocity after the collision because this VA and this VA are different.
So this actually just looks like a little.
It's just a little apostrophe, that's all it is, yeah. Yeah. So now I got 16 is equal to 8 plus 2 VB prime, and we call it prime. Can you solve this? I hate to tell you, but some of you still have problems with these solving of equations. How do we solve this? You got to get rid of the 8 first by subtracting. So to the other side, minus 8. 8 equals 2b prime. So VB prime is 8 divided by 2, or 4 meters per second. Is the arithmetic hard, like the math? No. The setup and the organization of it is what's hard. And it just takes practice. Surprisingly, or not surprisingly, like just whatever. Did you have enough space? Ready for the second one? Oh, those guys are still ready. Okay, so this time, both moving same direction. What changes here? Does anything change about the setup? Both moving same direction. Is anything different?
The first one's not pressed.
Does that change any of the setup? I don't think so. This is A. This one's B. Let's draw. Do I need to draw the picture again? Or can you do it without the picture, do you think? With? Without. Okay, this time I'm going to do it sort of in 2 stages and see if you like this way better. The initial momentum is equal to mass of A times velocity of A plus mass of B times velocity of B. Because I have 2 objects moving. So the initial momentum, the mass of A is 6. It's moving at 4 meters per second. Did you keep going on your own? Mass of B is 2, and the velocity of B is 3. So what's different here? Before it was 0. Ooh. So we got 24 plus 6, or 30 kilogram meters per second. Okay, so all I did different was, instead of doing it sort of simultaneously, I just did the left side first, right? And instead of that being 0, it was a number. Big deal. Okay. Then you might say something like, therefore, the final momentum is equal to 30, right? The momentum is conserved. And then you'd write PF is equal to, what makes up the final momentum? MAVA prime plus MBVB prime. I'm doing the right-hand side of this now, that's all. PF is 30. The mass of A is, again, 6. The velocity of A after looks like it's 2. The mass of B doesn't change, it's 2. Find the velocity of it, so VB prime. Take the 12 to the side, becomes negative. VB prime is 9. It's really exactly the same question, is it not? The only difference is there's a value there. The all it changed is that number, which you're just adding 6 and then that's different, right? It looks complicated. I don't dispute that. What about opposite directions? What's going to change?
Negative.
One of the velocities is going to be negative. Why don't you give that a try? I've given you the entire page, so if you make a mistake or screw up, I'll put the answer underneath, right? So you guys give it a try. Good for you to try. PI is equal to PF. What makes up the PI? Again, it's just two balls running each other, right? So it's going to be MAVA plus MBVB. It starts to get a little bit crazy after a while. MAVA prime plus MBVB prime. The mass of A is 1. The velocity of A looks like to be 3. Well, we got to be careful here. We got east and west, right? East and west. So strike 6 are moving west. So this is going to be 6 times minus 5, right? The mass of A again is 1. Are these not, like, as long as you put this in the same order, this number here in front is always going to be the same, right? If the final velocity of the 1 kilogram ball is 9 west, so that's going to be 1 times minus 9, right? Plus 6 times what we're trying to find, VB prime. Pay attention, you two. 3 minus 30 minus 27. 1 times minus 9 is minus 9 plus 6 VB prime. Minus 9 goes to the other side, becomes plus 9. Minus 27 plus 9 is minus 18 is equal to 6 VB prime. That's going to be minus 3. So, Chevia?
Good one, Will.
I got -4 on both.
You got minus 4?
We got -6 too.
How'd you get minus 6?
Will told me I was wrong. I couldn't right away.
Hey?
Put a negative on the 9.
Positive 9. I didn't read the last.
So then it was positive and you turned it to negative and then it was Thursday.
Yeah, so this is minus 9, so it becomes plus 9 on the other side, right? So minus 27 plus 9. Okay.
So I don't see how this is supposed to help us with that argument.
Let's go look at the Astroblaster question. The Astroblaster question, the height was 5 meters, right? And the masses were, help me out, 200, 200, 150, 150, I think, right? Am I right? Those are the numbers, 200, 150, 100, 550, and that adds up to 500 grams, I think, right? Which is 0.5 kilograms, right?
What was the answer to the question?
Minus 3? Okay. Now, the first part of the question says, if I'm not mistaken, how fast is it going when it hits the ground, right? So, this is kinematics. So, how fast is it going after it falls a certain distance? Vf squared equals Vi squared plus 2AD. Just like I told the grade 11s this morning, here's where physics, there's no need for a retest because every test has the same things over again.
Okay.
So then,
Just like Trek, physics is like an onion. There's many layers.
That was terrible, actually.
Okay, then it's like a parfait.
So I didn't go on this.
No, if you do the question right on this test that you did wrong before, then I'll change the one from before.
Where?
What do you mean, why?
No, you said only on the exam, not on
No.
the test.
Where it was your test.
What sense is to get it right?
He's trying to take it.
Okay.
I'm sure that you could convince me of that. But if you guys would just practice, you'd find that it's actually not that hard. Instead of trying to learn it the night before in isolation, think of physics as Shrek. Green and ugly.
I'd rather watch Shrek than
Yeah? What if I wore a Shrek mask while we did physics?
Oh, I didn't.
Yeah?
Wait, can we just?
What's the initial velocity? 0. Acceleration minus 9.8 times 5. 2 times 5 is 10, times minus 9.8 is, well, now, should it be negative?
No.
Because you're going to get this square root problem here, right? So really, the negative just is direction. So to make it work, we're just going to have 9.8. So it's you get a VF of, I think, down, am I right, 9.9? That we came up with? Oh, my shit's in here.
What's that one
Yeah,
number?
9.9.
98? 9.8?
Oh, 9.8, what a big difference.
Actually, it's 9.89.
Okay, now part B says, what is the total momentum when it hits the ground? P equals mv, the mass is 0.5, and the velocity is 9.9, and Joel has a question. No, we're just learning, man. Why, I'm doing it for you. Why would I give you mark for it?
What is it?
Okay, so the momentum is 4.95. So that is, would you agree, the initial momentum? Now, what do we know? We know that the initial momentum is equal to the final momentum. So therefore, PF is 4.95. We just got, this was A, and this was B. And I'm moving into C now. Now, COS, what is the initial velocity of the red ball when it leaves the device? Because you'll remember, kind of like a snowman, right? But which one is moving at the end? Only the red one. So has the mass changed? Because it's no longer the entire object of 0.5 kilograms. Now it's just the 50, right? So PF is equal to mv, which is the 4.95, and the mass of the red ball, 50 grams, or 0.05 kilograms.
It's 0.05. I was just kidding.
It's 0.05.
I was figuring 0 at the start.
So you get a velocity of the red ball, which is a whopping 99 meters per second, which is fast. Which makes sense because if the whole thing is going 9.9, right, the red ball is, Blair, I'm still teaching. Oh, you're calculating. Oh. Well, what am I supposed to think? You pull out a phone and you start.
She wouldn't do it in broad daylight. Yeah. She was actually texting somebody in the middle of your sentence. Like, who does that?
Yeah, you're right. Who does that?
Oh, yeah. So rude.
You will notice that the 50 grams is a tenth of the 500 grams, so that makes sense that it would be going 10 times faster, would it not?
Look at that.
So if it's going 10 times faster, now part D, how high does it travel?
Is that like how far it fell?
How far it's going to go up. The red one's going up.
I don't know what this thing is.
Yeah, I know you don't. So what's the final velocity when it gets to the top of the red ball? 0. The initial velocity is, yeah,
That didn't work.
yeah, that one. Now here my acceleration is minus 9.8 and we're solving for D.
Why?
Oh, does it shoot it up?
Yeah,
I thought we were dropping it.
we did. We dropped it and then it shoots it up. It bounces. I'll show you.
I got 99.
So you're going to take 99 squared to the other side. It becomes negative, and you're going to take the minus 19.6 to the other side, and you're going to get a displacement of 500 meters.
I got like 9,800 meters, so yay.
That
Ah.
that's like 9 kilometers.
I know.
Kind of.
Oh,
I never
Does,
thought it was
now,
right. I
does
never
this
heard
seem
it.
reasonable that if you drop that from, I mean, this is 100% bang on. That is true. Right? And you can easily drop it from 5 meters. That's not a ridiculous height. Right? All of this is true. The only thing that seems weird is the red ball is going to go 500 meters in the air.
well, it's going 99 meters.
That is true. All of this logic is true if momentum is actually conserved.
So gravity will?
Pardon me?
Gravity?
What? We've taken gravity into account, yeah. So, is gravity actually conserved in a rubber ball collision? Not even close. If you play, anyone play racquetball? I guess you don't play racquetball here in town, do you? You don't play racquetball. Do you? Squash?
Yeah.
The squash ball, when you play, Joel, does the ball, the way it moves around, does it change as the game goes on? Does the ball get more or less bouncy after the first few minutes? You don't know? It does. Racquetball, it's even more noticeable. Okay, I've played racquetball before. The ball heats up. How come? Because every time you hit it, it's a collision. See, now I think she's texting.
No.
No?
No.
Every time you hit it, it's a collision, and momentum is not conserved, and a lot of that energy goes to heat. So the problem here is it's not even going to be close to 500 meters. There's a considerable amount of energy lost, converted to heat. I will show you. Okay, I think I'll stop. I'm not going to, I've got some people away. I want people to practice. I'm going to do explosions on Monday. I gave you a one worksheet, right?
Yeah.
I should tell you which questions you can actually do. I get the feeling some